Hello, we're back and talking about monkey patching in PyTest again, and specifically we're going to be talking about why I don't like the monkey patch or the pytest-mock mocker fixture. I'm going to show you first a kind of preferential reason why I think they're problematic. Then I'm going to show you something that's actually really broken and comes from an actual production issue that I spent a long time debugging. And then I'm going to specifically talk about why the monkey patch fixture itself has an additional problem, and then another explanation for pytest-mock. So the first two things are going to be not specific to either of them. They'll apply to both of them, and then I'll talk about one specific thing for both those two remaining ones. Anyway, let's jump into it. So for this, we're going to be using pytest. Let's install that. I'm still using my old virtual machine, even though I set up the new one. I haven't gotten around to moving all the stuff over yet, but yeah, still an old one. Anyway, for this video, we're using pytest 911, and we're also going to install pytest-mock because I'm going to be showing stuff with it later. This is where the mocker fixture comes from. The monkey patch fixture comes from pytest itself, so you don't have to do anything to have that work and exist. I guess before I even talk about those two fixtures, the way that I tend to prefer mocking in pytest is to be using the context manager form of mock.patch.object. I still have to make yet another video where I talk about why I don't like mock.patch, but that's neither here nor there. We're not gonna address those here, but we're gonna show some problems with those. And so I'm gonna make just a really silly, simple test and kind of show how it would work for these three approaches, even though two of them are kind of the same. And then we'll go into some problems. So I guess the first is to show how I would do it. This is gonna be a really dumb test. I'm just gonna mock os.path.join. There's really not a reason to mock that. I guess it is different per platform, but you should probably make your tests not really care about platform differences or bake that into an assertion helper or something like that. But anyway, let's make a test, and we're going to mock.patch.object os.path.join. Let's say we'll always make it have forward slashes. Maybe this is running on Windows for some reason. I wouldn't recommend this, but it's just a silly example. And some of the code later will look especially silly, but trust me, this is the simplest way to explain this. And in much more complicated systems with thousands of tests, tens to 20s of test helpers and hundreds of developers, you're going to appreciate the simplicity of this example relative to a giant code base where I've actually extracted some of these learnings from. But anyway, so we've mocked out os.path.join. We can now say assert os.path.join. I'm even going to pass in values that don't make sense here, just to show we're forcing os.path.join to return something else. So this is kind of how I would do this. Obviously, I wouldn't mock os.path.join, but we want a simple example. This one's easy to explain, so let's go with that. We run this, it passes, great. That's working fine. If we change this to instead use either the monkey patch fixture, we would instead do monkeypatch.setAttr, and instead of return value, we would use lambda star a to take all of the positional arguments and then ignore them. So one, it seems like a nice improvement here in that we have one fewer level of indentation. Anyway, you can debate whether that's more explicit, less explicit, better or worse, but it does work in this particular example. I didn't fill up my water. I guess no slurps for this video. So let's talk about, and obviously the same thing, if you use mocker instead, you would use mocker.patch.object, similar to how we had used the unit test mock.patch.object. pytest-mock and the mocker fixture are basically just a way to access this in a more convenient manner. But it works the same as monkey patch fixture, well, similar to monkey patch fixture in that you call it and you don't really do cleanup. The cleanup kind of happens for you. And to me, that is the first kind of unfortunate problem about this, in that you don't have a great way to control the scope of when you call these. Yes, there are context manager versions of both monkeypatch.setEditor and the unit test or the pytest-mock fixture as well. But at that point, just use the you're not really saving yourself with anything with that. But you don't really have a great control over the scope of this. And so you might ask, okay, when does this actually get torn down? Like how long does this last for? And you might imagine that it gets torn down at the end of the function. However, if we make a quick decorator, we can use the trick from the other video where we can make a context manager that's actually a decorator, and look at, I guess we can just do s.path.join C and D. So normally, like, I would hope for this function here that, or any monkey patching thing that you're doing, that you're narrowing the scope to as small of a scope as possible. In the same way that, like, if you're writing a try except, you don't really want to broadly accept a ton of code where an exception could happen. You want to narrow it down to just the little piece of code where it could fail. And especially when you're doing sort of a invasive operation like monkey patching out a module, you're changing internal functionality that might break code that doesn't expect it to be that way. You kind of want to narrow down the scope of where you're patching something to as narrow of a scope as possible. My usual rule of thumb is to only monkey patch for like a single function call. That way, when you're running your assertions, you're not in a patch state. Like if you're calling some helper function after you've run the system under test, you're not in a patch state. You're limiting to as little as possible. However, I think I need parentheses here. I should rewatch my video on this. However, if we look at how this executes, like you would hope that the patch is disabled by this point. However, the monkey patches live on beyond the scope of where this function happens. We need -s to show standard output. I suck at imports, I guess. Yeah, so you can see here it printed 1/2. So this patch here was still alive even after this function finished. And in fact, like sometimes you can even have other fixtures here. So if we did pytest.fixture, and this also uses the deck fixture here. Sometimes even fixtures will still see the effects of patches from functions as well. I forgot to import pytest. Okay, there it actually, it tore it down before this. Is it based on ordering? If I put this fixture here, does it change how this works? Yeah, so you can see here, just based on how I ordered them in the function, this was still live, which is kind of a surprising behavior, like something you probably don't want to happen. But it has to do, like, the way it actually tears down this is it uses a finalizer inside this fixture and tears it down at that point. So you might set something up and it's not going to get torn down until the actual test object itself is being torn down, when fixtures itself are being torn down. And so you might leak this patch into places where you don't want it. And this applies for both monkeypatch and for pytest-mock as well. So that's kind of the first thing that irks me a little bit, in that you don't have great control over the scope of these patches. They kind of leak all over the place. Now, they're still, at least so far what I've shown you, it's still somewhat safe in that we're not leaking outside of this test. But I'm about to show you a thing that I found that was kind of my initial wake-up call to this is kind of annoying in that I don't control the scope very well. But the thing I'm about to show you next is actually a big problem, and was something that took me a really long time to debug and find in a real production code base that was running into this problem. And that is, these, when mixed with other ways of monkey patching, can leak their guts all over your code base in a way that never gets cleaned up. So let me show you a quick example of that. We're going to use this same os.path example, but I'm going to show you using the monkey patch fixture with the context manager based monkey patching as well. We're also going to do test 2 here, which is not going to mock at all, and this is going to show that our patch is being leaked, if I've written my example correctly. It's been a while since I've tried to show this. But I believe the example is with mock.patch.object os.path join, and we'll do the same return value equals, let's do 3/4 here, just so that we have something different. Let's say that you know, maybe one of these comes from some testing helper that you're using, and maybe this is from the test itself. But you can imagine a world where in a very large code base or a really complicated code base or a really complicated test suite, you might have a mix of these strategies, especially because, you know, if you're only using this strategy, I mean, if you're only using this strategy, then you're probably fine, unless, I don't know, maybe you're using a third-party library that also patches in this way. And yeah, it is a little bit weird to patch the same thing twice, but it happens. So any sufficiently large code base will have these sorts of complexities baked in, and so you might run into this particular scenario. But let's put some assertions here just to show that this works correctly. Assert os.path.join, what was it? A b is equal to 3/4. So first patch applies, we get 3/4. Second patch applies, we get 1/2. Cool, great, whatever. And then we hope that both of these patches are torn down, and eventually we're able to replace the one at the end. So if we run this, unfortunately, whoa, what happened here? Oh, this is even worse. Okay. So I was expecting this failure here. So, you know, this unpatched state should join to CD, but you can see here that we've leaked the patch from before. We've leaked one of the two patches because we've mixed the ways of calling this. But it's even worse than that. Not only did we leak this into our test, we actually leaked it into pytest itself, which broke the cache fixture. So it broke some like weird internal in pytest because we mixed these two ways of doing monkey patching here. And so I guess to explain what happened here, well, and actually I went and looked this up before the video. I actually talked about this on stream years and years ago, and I made this like kind of nifty paint diagram. I'm too late for Pride Month by one day though. Whoops, oh well. But this kind of explains sort of what's going on here, in that like you kind of want your setups and teardowns to look like a triangle, in that like each of them is set up in order and each of them is torn down in order. However, if you end up in these cases where something is torn down too early or too late, I believe in this case it's too late. I think this one is a setup too early, but either way, you're going to end up in this sort of jagged state where it's going to patch in a value from something that's already patched or in a state that's not returning it to the previous one. So you can kind of imagine this context manager is like, I mean, monkey patching in general is like, setup is like 1, get the current object and save it, and then 2 is run the code, and then 3 is, well, and then tear down. I guess this happens in between. It's not really the part of that. Step 2 is replace the object. And then teardown is something like just replace the object with the save object. So you can imagine like if you ran a bunch of these patches in order with this particular method, like you're grabbing the value, you run the code, you tear down the value. You kind of end up with this like symmetric thing here. But as soon as you end up with this one here, you've set up the value, then you set it up again, then this one tears down, which actually does correctly restore the original thing. So if we do assert os.path.join E and F, this actually works correctly. This assertion will succeed. But then this teardown happens after the scope of this function, and it's actually when it got called here, the object that it saw was this mock object here. So it's leaked this mock object into the rest of the process and sort of polluted your global state. You can see here, I didn't expect this to happen. That's kind of, I mean, I sort of expected it to happen, but I didn't expect it. I was surprised. I guess we'll say that. But you can see here that first test is still passing, even though, like, we eventually, after tearing down this test, end up in a broken state where this gets leaked to the world. And so that's kind of the second problem with both monkeypatch and the mocker fixture. Last I wanted to talk about like some I guess less impactful, but it's like kind of specific gripes that I have with the two of these. The first is that the monkeypatch fixture, even though it's built into pytest, which is kind of nice, and even though it's really, really simple, it kind of has a history of being pretty behind how unit test.mock works. And yes, monkeypatch technically predates unit test mock, so you would hope that it's a little bit more stable. Unfortunately, it's sort of not really gotten as much, rigor as the, unit test mock module. This is kind of a weird case. Well, I guess, unit test mock didn't start in the standard library, but was kind of inspired by it. This is kind of a case where like this was so much more popular than monkeypatch, and so it got a lot more features put into it and it was a lot more battle tested. Whereas monkeypatch, like, it really only works for the basic simple cases, and even then, like, it still has the problems that I showed in this video. So I'm always a little bit weary about weary? I don't even know what the phrase is. Whatever the phrase is, about using the monkeypatch fixture. And for pytest-mock, it's essentially just a small wrapper around unit test.mock that has all the problems I've shown in this video. And so there's this kind of, maybe this is me being a little bit philosophical about large pytest code bases. There's this sort of problem with pytest code bases where people realize, oh, hey, you know, if I make a fixture, I don't have to import anything. Like, it's just magically available. And importing is a pain in the butt. So what if I just make a fixture for all my imports and then I don't ever have to run import again? And this is kind of a trap that a lot of people fall into, and that it makes it, one, it makes it a lot harder to like figure out what your test actually uses. Two, it bloats your fixture namespace, so you end up with just like hundreds of mildly useless fixtures. And three, like just import it, man. Like, oh no, it adds a line of code because you have to run an import. It's going to be a lot easier to understand what's going on if you like explicitly know what your import is and like, you know, use it down here. But for whatever reason, you know, some people are like, oh, you know, gung-ho with fixtures, use a million of them just to save imports. And that really rubs me the wrong way. I guess the other part about it is, man, the LLMs really love this fixture. And so like they'll propagate this pattern anywhere in your code base if you let them. So I really don't like that part about it. But anyway, yeah, so this is monkeypatch and pytest-mock and why I don't use them and why I recommend always using the context manager form of this. I guess there is also the decorator form of monkeypatching, which again, like, I like to limit the scope of where my patch lives. Yes, the decorator is explicit and it does have a limited scope. Like, it will only apply for the function you're decorating. I guess the example is like mock.patch.object, whatever. This will only apply the scope to this function, which is nice, but you're likely going to have more than a single function call in here, and you might not want it to be patched for the entirety of that function. So even in those cases, like, I tend to avoid the decorator form as well. Not to mention the decorator form also mutates the signature of the function, which also really rubs me the wrong way. But this is bonus. This isn't related to the fixtures. But anyway, I'll just grumble about this forever. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.